Welcome to the spring 2021 version of the Electrical and Computer Engineering Technical Elective and Accelerated Master's Program, or AMP, information session. To get us started, you might be thinking about the classes that you have taken or will take as sophomores and juniors. If you noticed some kind of pattern, that's not unplanned, and it sort of allows you to have some feel for where you might find technical elective courses relative to the numbering strategy. For example, electric circuits, circuit theory, those are in the 20s. Communications, Introduction to Communications 340, that's in the 40s. We don't have a signal processing class in the junior and sophomore years, but if we did, it would have maybe a 30s number. Those are classes in the signals and systems area, and so you'll see classes that are related to control theory, communications, signal processing, mostly with numbers in the 20s, 30s, and 40s, in the 400s, 500s, 600s, etc. Similarly, if you are remembering your electronics classes, those are in the 50s. We have our optics and electronics courses usually in the decade of the 50s. Our computer classes, consistent with 175, 275, 369, those are in 2 decades, the 60s and 70s. Electromagnetics are in the 80s, and we've run out of room for a lot of our classes. Some of our classes will then be in the single digits. But that gives you maybe a feel for the structure of our numbering, and now you might be thinking, okay, how do I pick technical electives? And a couple of things to keep in mind. One is, can you predict the future? And probably you can kind of anticipate what might happen in the future, but it's maybe challenging to predict the future. With that said, you might try to keep an open mind and think about not just focusing on any one decade or one particular sub area in this broad topical area of electrical and computer engineering. I would recommend that you start picking from different topics, like some from signals and systems, some from computer. Even if you're in an electrical engineering option, or if you're in a computer engineering option, you might actually take an electromagnetics class as a technical elective. Why might you want to do that? Well, don't view these technical electives as just in individual silos. A lot of technical innovation actually comes into being by crossing these sort of disciplinary boundaries, and these are disciplinary boundaries within electrical and computer engineering. So as you're taking these technical electives, be thinking about how they are interrelated or how you could connect one with the other. And I think that will go a long way in helping you enjoy your technical electives and see how you can now benefit by taking different technical electives in the various decades or sub-disciplines within electrical and computer, be that signals and systems, electronics, electromagnetics, or computer. Also, as you're planning your technical electives, if you want a little bit more information, you might check out these links, which are available from our website. If you go to the ECE website and hover over undergrad programs, you should be able to click on courses and find now the courses, mostly, hopefully most of them are there. And if you want to see the syllabus, then you can click on that link and obtain the syllabus, which really gives you a description. It maybe lists the textbook and it probably provides topics. That now gives you more than what I might be able to explain today. And in some of the classes that are not dual numbered, you might want to go back to the website, click on grad programs, highlight courses, and then you'll go over to these classes that are not dual numbered or not jointly 400, 500, but you are, as a senior and even a junior in electrical and computer engineering, you can take 500 level classes, even 600 level classes if you want, but 500 level classes, even if you aren't in the Accelerated Masters program. But I will be listing different, well, all of the classes. If you see now in this listing, I've included some 500 and even 600 level classes because you have those available to you if you have the appropriate grade point average. And a lot of you do have the appropriate grade point average, and so you don't have to restrict your attention to 400 level courses. In the fall, here is what you can sort of plan on in the computer area. Fundamentals of computer architecture. Obviously, if you're in the computer option, that's not a technical elective, but if you're in the electrical engineering option, you can take that class. And now you'll start learning about the different parts that make up a computer: the CPU, the memory, the registers, the arithmetic logic unit. Obtain some assembly language knowledge, and again, continuing from 274, you'll be playing with FPGAs. So if you enjoyed that in 274A, you might think about taking 369A and learn how to push the envelope of building a computer beyond maybe buying the little parts or the pieces to construct your own PC at home. 373, object-oriented software design. That's a logical extension from 275, but here you're focusing then on data types, classes. You'll have a project to put all of this together. 411, 511, if you want a class on modeling. Here, physics-based systems, biological systems. You'll learn about neural networks. You'll have opportunity to learn numerical methods for describing these physical systems that are physics and biologically based. So if that's of interest, that would be a good class to take. Web development and Internet of Things. A lot of devices now are connected to the internet. How do you design a web interface? How do you connect all of these systems with wearables, autonomous vehicles, smart, you fill in the blank, smart grid, whatever you want to think of in terms of smart, now you can. And this now actually gives you the opportunity to investigate Internet of Things, and that has a project typically, and now you can do that in the Internet of Things class. Computer-aided logic design. That's an extension of 274A. If you liked 274A, then that's what you may want to look into. That's a good follow-on for 274A. Fundamentals of computer networks, protocols, security policies. You'll have some hands-on experience with how do computers actually communicate or talk to one another. If you're interested in security, computer security, 509 is a cybersecurity class. How do you identify threats? What's a security policy? Again, that will have some hands-on applications or projects. Engineering of computer-based systems. Now, these are complex systems that involve software and hardware, artificial intelligence, simulation. knowledge, bringing knowledge-based systems, and again a project. How do you put all of those pieces together? Distributed computing systems, you might think of what we do typically in a computing system. Now what happens when those are distributed? Not all in one location or processor. How do you do operating systems when they're distributed? How do you do file systems when they're distributed, etc.? In the electronics and bio courses area, right now it doesn't look like that class 434 will be available in the fall, but stay tuned. If you're now yet to be going into your senior year, think about taking that in the fall of 22. This is now sort of allowing you to interrelate optical systems and electrical systems. You're here at the University of Arizona. We have a very strong optics program. You might want to take advantage of these classes, and this is not the only one that combine, or you start learning about how to combine electrical and optical systems. Conductors, insulators, semiconductor, those three types of materials are talked about in 434. Semiconductor processing, how do you manufacture all of these little devices that you're learning how to build or create? Analog integrated circuits, you might think of this one as sort of a high-level way of physical reasoning. How do you now look at a circuit and say, oh, this is what this circuit is doing functionally? That's analog integrated circuits, so you're going beyond 351C, obviously. Then another class that's really somewhat in between the computer courses and the electronics. Maybe this isn't in the right location. I should have maybe put it in the computer area. This is now design, modeling, and simulation for high technology systems in medicine. If you've been in a hospital environment, or now maybe you'll get to play with the Da Vinci robot that's physically in the ECE building. I'm not sure what will be done in that class, but you can just imagine, if you now think about the different devices available to you in the hospital environment, how do you make those work? How do you design and model and simulate those devices? And also, maybe, how do you train physicians to become more effective? If they're doing surgery, maybe you want to design particular systems that allow them to be trained on those complex pieces of equipment. In the electromagnetics and optics courses, a follow-on to 381A is electromagnetic field theory, waveguides, aperture, scattering. How does that all become modeled? How do you describe that? That's in 581A. Again, here's another one that bridges the optics and the electrical engineering, fundamentals of optics for electrical engineers. Geometrical optics, how do you build those? Holography, now optical data storage, optical processing. How do you do some of these traditional electrical signal processing concepts with optics? 486, 586, microwave engineering 1. Now you're dealing with devices that are in the microwave frequency range. They sort of pick up with transmission lines. How do you design filters, amplifiers, transceivers, integrated circuits? That is now covered in 486, 586. 527 talks about holography, so now your interference and gratings. It has labs. That one usually is alternating between 459 and 527, so think about maybe taking that in the subsequent fall if you have the opportunity. In the signals and systems area, we have digital signal processing, Z transforms, filtering, Optical communications, if you're excited about 340A, Introduction to Communication Systems, now what are some of the issues for doing that optically? Digital image analysis isn't planned right now for fall of 21, but stay tuned. It will probably roll back in fall of 22. Free space optical communication systems. Now if you have a laser that's going from point to point, how does that signal propagate? How do you model the channel? Usually we think of the channel as like wires that connect different devices or optical fiber. Now if that's now free space, how do you deal with distortion? How do you make those correct for those distortions that occur in that free space optical systems? Digital communication systems 2, that's a follow-on to the digital communications that's 435A, 535A, that's a spring-based class. So if you take maybe next spring in the 435A, you could now take this in your last semester, or another fall semester is 537. If you're interested in radar signal processing, synthetic aperture radar, that's covered. How do you deal with distortion, Doppler? Those are the issues that you might see in radar signal processing. Automatic control systems. Now, how do you model systems? How do you modify the behavior, make them behave more the way that you want them to behave? If you're interested in robotics, autonomous vehicles, anything that you think you might want to control, that's where you get the theory behind those concepts. 501B, this is obviously a little bit a step up from just the mechanics of linear algebra. Now you're talking about maps and operators, inner products in a more general way, and you'll think of those in terms of finite and infinite dimensional spaces in 501B. 503 is now probability and random processes. How do you model or describe random variables, stochastic processes, processes that now have noise or random signals associated with them? I should mention, and hopefully some of you are watching this that aren't going to immediately step into your senior year, but you're actually going to start your junior year. You should probably, if you're interested in the entrepreneurship sequence in the McGuire Center, you probably should take that as a junior. It is available to ECE juniors. It's a 2-semester sequence. It conflicts time-wise with the capstone sequence in engineering, so it will be allowed. You can count this towards your technical electives. You can use these two as technical electives, but you can't take the entrepreneurship to replace the engineering capstone. That's why you need to take it while you are a junior. As you're planning all of these out, I hope some of my recommendations as far as interconnecting these different topics are resonating with you. But now if you're saying, oh, I want to take this, okay, if you take it based on it fits in your schedule, still think about it as, oh, what can I get out of this class? How do I now learn from what's being discussed? Here, some of these that are maybe crossed down in blue, those are yet to be determined. They may still arise. That's 576A. 537, again, that's the Digital Communications 2. Maybe you'll take that as a graduate student in your, if you're now in the AMP or going to be in the AMP, maybe you hold off and take that while you're a graduate student, and it might be available then in the subsequent fall. But here what you're wanting to do is, obviously you can't take multiple classes in the same time slot. So if you do see class or classes, hopefully not, but if you do have conflicts, you'll want to start selecting the one that's of most interest. If you now have 3 semesters left, maybe you can plan ahead and actually take 2 of those, one this coming fall and another one the subsequent fall. Then I think it's helpful to be thinking beyond one semester in the future. I said we can't predict the future maybe, but we can plan. Now in spring of 2022 and in fall of 2021, we're trying to be coming back with a more reasonable looking campus environment. We're trying to put everything in person for fall of 2021 and obviously spring of 2022. But here are the classes that are being planned, and again, we're sort of projecting these. Some of these may not happen, but we have 330B. That's available to both electrical engineering option and computer engineering option, computational techniques. How do you actually numerically differentiate? How do you numerically integrate? This class talks about optimization. How do we perform optimization with a computer? And how do you do that? Simulated annealing, genetic algorithms, those you will discuss or learn about in 330B. Computer architecture, if you liked 369A, now in 369A maybe you learned the fundamentals, the basics. Now in 462, think about it in the design sense. What are some of the trade-offs? How do I trade off these different pieces, the CPU, the memory? How do I put those together in a design concept? 466, knowledge system engineering. I like to think of that as sort of AI 2, but it doesn't have 479 as a prerequisite. So you could actually take those together as 466 and 479. Here in 466, how do you represent knowledge? How do you process knowledge? 571, cryptography. How do you make your systems, information and networks secure? That's now 471. Artificial intelligence, that's now AI 1. How do you build a computer to actually be able to sort of think or reason? Build a game, that's maybe one way of thinking about artificial intelligence. You're now playing checkers. How would you actually allow a computer to do that for you? Reconfigurable computing, how do you build reconfigurable devices? Fundamentals of cloud security. That, I think, a lot of technology is going or moving to the cloud. How do you ensure that that information and that process is being done securely? Wireless protocols, if you were thinking about communicating, now how do you do that wirelessly? Device electronics, that's now available to the computer engineering option students. PN junctions, how do you talk about carriers in electronics? 407, now you're thinking about MOSFETs, CMOS. Maybe you were doing mostly bipolar in 351C. Now you're starting to build inverters and logic gates in a different technology. 417, 517, how do you measure physiological systems, and how do you do the signal processing? Now that you've sensed that, how do you now obtain or use that effectively in a system? Introductory Electromagnetics, that's a technical elective option for the computer engineering option students. Electrostatics, magnetostatics, Maxwell's equations. If you always wanted to know what was on somebody's t-shirt that had Maxwell's equations, now maybe you can get a better understanding of how these electric fields and magnetic fields play together and allow information to be propagated through space. Photovoltaic solar energy systems, if you're into energy, power, now what devices are possible in terms of photovoltaic? How do you design new ones or enhance existing ones? 455, Intro to Quantum Mechanics or Quantum Information Processing. Photon polarization, spin, how do you deal with that? And, oh, I need to understand some quantum mechanics. That you will get in that class. Optoelectronics, again, that's this combination of optical and electronics. Antenna theory, how do antennas work? How do they radiate? What's their pattern? How do you design them? What if I have now an antenna array? Our devices keep shrinking, but yet we need to be communicating and having good transmission and reception of those signals. That is very dependent on the antenna. Advanced topics in optical and electronic materials. That's now waveguides, nanomaterials. Again, this is the interchange of optical and electronics. Machine learning, if you're interested in machine learning, how do you classify or identify unknown systems? Digital image processing. Now you maybe need to do some transforms on an image, or filter, or enhance, restore, compress, error detection, etc. All of those are a part of 533. Here's the digital communication system. How do we translate information into a digital form? And then how do you extract the useful information from a received signal that now has had to go through a channel, and maybe it's been compromised a little bit, but how do you design it initially so that even if it is compromised, you can extract the known information from that waveform? Digital control systems, again, you're playing with the Z-transform, and in a discrete time setting, how do you now adjust behavior of systems? And maybe this is a stretch, but if you're interested in information theory, what's the capacity of this channel? It's noisy. Now, how do I do error detection? How do I understand how to encode information? And another related topic is detection and estimation. What's the optimal detector that you can build? How do you extract signals from noise? Those are now the technical contents from the classes that we are expecting to have in place in the spring semester. And you can see that I didn't include 304A. That will probably start alternating years. That's the plan, so that's why it has a red line. So if you're 3 semesters out of graduating, that can maybe be slid in to your final semester. But this again gives you the outline of where the schedule of when these classes are right now planned to be offered, and you'll have to then make a choice between 1 or 3 of those if you were interested in all 3. This was the Technical Elective and AMP information session, Accelerated Master's Program. It's a good choice if you're thinking about getting a master's, let's say in 1 year after your BS. You can apply during your junior year. You have to have 75 units, undergraduate units, and a lot of you have that in your second year here. You have a cumulative GPA of 3.3. You don't have to take the graduate record exam. That's not required if you want to get into the Accelerated Master's program. You'll submit your application in your junior year, and now you'll work with your undergraduate advisor and your graduate advisor to come up with classes that you want to take, and you can start taking those in your senior year, which means, when you have 90 plus units on your transcript. This now allows you actually, why do we call it accelerated? Well, this allows you to actually take up to 4 classes at the 500 level that count towards your undergraduate technical elective content, and you can also count those same 4 classes towards your MS degree. If you are now taking an all coursework based MS, that would consist of 10 classes. Well, now you've already satisfied or accrued 4 of those, so now you need to take 6 in the next year in order to obtain your master's degree. If you're interested in the Accelerated Master's program and have some questions, I recommend that you email Tammy at gradadvisor@ece.arizona.edu, and I hope then that this video was helpful in getting you to think about what you want to do technical elective wise, and it's only going to be 1 more year. Staying in school for 1 more year allows you to have a BS and an MS in 4-5 years, depending on where you're at in your process of your educational system. Good luck with your choices and have fun. Again, think about how you can connect these different elective courses and become very innovative in your future.